If you look at example 2, once again, we do need common denominators to be able to add or subtract fractions. And you'll notice here that the denominator x squared plus 3x and the denominator x times x plus 3 are in different forms. Okay, so we have to verify that they're the same before we can do this. So if I go ahead and do this, I'm going to factor x squared plus 3x. There's a common factor of x. If I extract x out of the expression, x plus 3 is left over. When you're trying to make common denominators, a factored form is better than a simplified form. So this is simplified, this is factored. Factored forms are better, so breaking that down is better.
So you want it to be x?
You do want them both to be factored so you can compare them more easily. Okay? And once you see that they're exactly the same factored form, this is x times x plus 3, that's x times x plus 3. This already was factored, so leave it factored. Right? Then you have a problem that can be worked out since they have a common denominator. Again, this is 2x plus 1 on top. This is 3x minus 8 on top. The tops are better suited to be in simplified form. So keep the top simplified, keep the bottoms factored when you're comparing these fractions. Now to be cautious here, this is the part where we need to pay attention to detail. We need to be careful with what's going on. When you're subtracting fractions, you're subtracting the numerator of the other fraction. So it's minus the numerator. The numerator is both things here. So when I see a minus in front of a fraction, I'm not going to quickly just write stuff down. I'm going to carefully write stuff down that's happening here to make sure it's done correctly. So what I'm supposed to do is I'm supposed to take the first numerator, 2x plus 1. I'm supposed to subtract the second numerator. And when I subtract, I'm subtracting each piece. So I'm subtracting 3x. What
Down below, it's supposed to be
plus 1, thank you. 2x plus 1. I'm subtracting the 3x and I'm subtracting the negative 8, so it makes a plus 8. This sign here is missed by a lot of people if you're not careful. All right? And I wasn't careful writing my numbers, so 2x plus 1 instead of 2x plus 2, right? That's me not being careful. But again, this is a very easily overlooked idea. Subtracting multiple objects, we're subtracting each and every piece. So minus positive 3x and minus negative 8 makes plus 8. That plus 8 is quite often missed by people, so be careful that when we're subtracting, that we allow that minus sign to hit every piece of the numerator. Once I combine those numerators together like that, I'm going to put that over the single common denominator of x times x plus 3. Again, once the common denominator exists, once this is the same as this, that's what goes on the bottom. What's left to do on top now, if possible, we need to combine like terms, and notice there are like terms this time. So we do have the 2x and the minus 3x, and we have the plus 1 and the plus 8. So the end result of this, if I combine my like terms, 2x minus 3x makes negative 1x. Subtract because the signs are different, and negative because 3 is bigger than 2. 1 plus 8 makes plus 9, adding because the signs are the same, and positive because 8 is bigger than 1. And that all goes over my x times x plus 3. That's what I'm looking for an answer. Again, simplified numerator and a factor denominator. And finally, for my domain, my original problem is right here. My denominators are x and x plus 3. So x is not allowed to equal 0 or negative 3.